In this video, we build on our concept from last time how to build a truth table for more complicated compound statements involving if-thens and if and only ifs. In other words, the conditional and the biconditional. Let's get started. So recall that a tautology was a compound statement which was always true. Good job. You can fill in your first blank with me. I think I even mentioned in our last video briefly that a self-contradiction was a compound statement which always was false, right? Because it's always contradicting itself, a self-contradiction. But one new term that you may not have heard of before is the term implication. Now you use this in the English language a lot, like this implies this, right? But when we mean an implication in logic, what we're talking about is an if-then or a conditional statement, like if P, then Q, which is a tautology. So it has to be an if-then statement. That's the first criteria for your notes. And it has to be a tautology. So it has to both be if-then and always be true. If so, we call this an implication. Implication. All right, so let's take a look if our next compound statement on this slide is one of these three, tautology or a self-contradiction or an implication. Let's see. So we have this compound statement here. In parentheses, it reads P and Q, then it closes parentheses, and parentheses, not Q or not P. So what is this saying? Well, let's assume that P was the simple statement, Bo ate cake, and Q was Bo ate pie. Then how would I read this in English? In parentheses, it says, Bo ate cake and pie, and he did not eat cake, or he did not eat pie. It's kind of a weird statement, but that is how we would read it in English. Now let's determine if this is always true, if this is always false, and then see what that would be called. Well, you can skip ahead if you just look at the very last column here, and you notice that in all four cases it is false, right? So if we get an F at the very end here, false, 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 and false, what should that be called? If it's always false, it should be called a self-contradiction. And maybe you could already tell that when I read the statement in English, it didn't seem to make a whole lot of sense, right? But don't always trust your instincts when you're dealing with a logical problem, because we might be off, okay? If you want to know why or how they got that result, look back on our previous video to determine how to make a truth table with and or and negations, and you should be able to come up with that yourself. When you're ready, let's head over to our next slide and build on this knowledge. On the next slide here, we're going to talk about under which conditions a conditional statement, like if P then Q, would be false. Now already, this is a little bit different. In your notes so far, you should have from your last video the conditions for when the or statement, the and statement, when they're true, right? But when we're talking about the conditional statement, we're more interested in when is it false, right? If you think about an if-then statement as like a promise, right? If you do well on this test, then you'll pass the class. Maybe some professor has told you that in the past, right? Well, there is one case, okay, where that is not true. And that would be the case where you did your best in the class, but then you didn't actually pass, right? So the promise was kept, but it wasn't, sorry, you met the condition. The condition was met, but the expectation wasn't delivered. In that case, the if-then statement is false. And that's what we're writing here. We're saying that if the P, if the antecedent or the condition was met or was true, but the consequent Q, or the expectation, was not delivered, right? Was false, then that would be a lie, right? That was not a true promise. Okay, so what we're saying, in other words, if you have an if-then statement where the first, the antecedent is true, but the second or the consequent is false, this is the only case where you have a false conditional statement, okay? So this is the only time when we have a false conditional statement. Any other time, it will be true. Why is that? Well, what if you have your first condition false, like you didn't even meet the expectation, you didn't do well on the next test? Well, then I haven't lied as a professor, right? If you didn't meet the condition, then I don't have to promise you anything, right? So notice if you have a false and then a true, that is still a true statement. It wasn't a lie. Okay, so let's take a look at an example of how this could work. Let's suppose, for example, that statement P was you do a little bit each day. Maybe this is your homework, maybe this is something else you're working on. And Q is you get by. Okay, so what does it say here in our compound statement symbolically? Parentheses P, arrow Q in one direction, so that's an if then. end parentheses, and then it has the and connective. Then it opens a new parentheses, negation of P, arrow, so that's a conditional if then, not Q, close parentheses. So how would I read this in English? Well, I would say, in parentheses here, if you do a little bit each day, then you get by. And if you do not do a little bit each day, then you do not get by. Now, these two sound very similar. In fact, a lot of people think they're saying the exact same thing, but we're going to find out in this truth table that they're not always true at the same time. In other words, they're not equivalent statements. We'll talk more about that in our next video. But let's see why that is. So for a truth table here, you'd begin by writing your P column and your Q column, and notice there are only 4 rows. We talked about this in our last video because there are only 2 simple statements here, P and Q, okay? So 2 to the second power is 4. Then we did half true and half false, TTFF, and then 1 by 1, TF. Now here's the new column that we're going to take some time on, okay? And that is the if-then column. Now why do we do this one next? Because it's in parentheses here, okay? So P, then Q. So when is that statement going to be false? When is a conditional statement false? It's only false when the first is true, but the second is false. So the condition is met, but the expectation is not delivered, right? And that happens in this second row here, doesn't it? The first is true, but the second is false. That is why the second row is the time when it's a false statement, okay? In every other case, notice true then true, that's okay. False then true, that's still true. Why? Because you didn't meet the person didn't meet the condition, so you can't say that the person promising them something lied because they didn't meet the expectation. Okay, so that would be a true statement, and so would false and then false, right? So if you didn't meet the condition and I didn't deliver the promise, that still doesn't make the promise false because you never met the condition to begin with. Okay, the next thing I would do is I would notice that we have this and connective here. So we will be joining that original column with what we see in the next parentheses. So in the next parentheses, what do we have? We have negations, that's right. So we would need to build out that entire parenthetical statement, probably beginning with the not P column and a not Q column. So that's what we see happening here. The not P column, remember from our last video, that means go to your P column and just take the opposite. So instead of the P column, which was true, true, false, false, we now have the opposite. False, false, true, true. So that's what we see happening here. The T turns into an F, the F turns into a T in those cases. Similarly, for the not Q column, we took the opposite of the original Q column, which was TF, TF. So instead it should be FT, FT, and that's what we see here, FT, FT. But now let's look at what might be a little bit unfamiliar to you, and that is putting them together. Let me grab another color here, like purple. Putting them together for what's in parentheses here. Parentheses, not P, then not Q. So what I need to do here is find the not P column, which is right here. I need to find the not Q column, which is right here. I'm joining them together, but in our last video, we would join them together with like an and symbol or an or symbol. Now the connective is if-then. It's a single arrow pointing to the right, the conditional. So for the if-then, what was the only time when an if-then statement is false? What is the only time when an if-then statement is false? If the first is true, but the second is false. That's right. Does that ever happen here? Do we ever have a falsehood? The first is true. That happens in these last 2 cases here. Notice the order matters, right? Who's first? In this case, not P comes first, so we're looking at the not P first. It's true in these 2 conditions, right? And is it ever false for the conclusion? Yes, in the 3rd row. So in this situation, that's where we're going to have our falsehood, right? T and then F, that delivers that falsehood. Okay, notice all of the other times you can put the true, 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 okay? So it's only false if the first is true and the last is false for an if-then statement. So you want to have those in your notes, really nice, ready to go. Now finally, we put it all together with our big connective. Our big connective is and this time, right? So we're going to join together the 2 parenthetical statements with the and. So let's find them. The first parenthetical statement was, I'll use my colors here, orange. It was this P then Q, so it's this statement up here. And the second parenthetical statement was my purple one. Let me grab him here. Parentheses, not P, then not Q. I got ahead of myself, got my mouth. All right, so that would be right here. Okay, so we are putting those 2 together with what connective? This time we're not using an arrow connective, we are using an and connective. Look back in your last video notes, if you can't remember, when is an and statement true? If they're both true. Very good. So let's look carefully at those two columns. Are they ever both true? In the first row, they are both true, aren't they? So that's why this turned out to be a true statement. But in the other ones, they're not always both true, so they're falsehoods. So this would be TFF, and I looked at the last one too fast, and the last one is actually a truth as well. So it's TFFT. TFFT. So it's true in the first case and the last case, and it's false in the second and third case. Now, would this be what we call a self-contradiction? No, because it's not always false. Is this what we would call a tautology? No, because it's not always true. Well, finally, could it be an implication? Well, no, because an implication had to be an if-then statement. Well, it's not even an if-then statement, is it? It's an and statement, so that already rules it out. But even if this was an arrow instead, if this was an if-then statement, this still is not a tautology, so this cannot be a self-contradiction. All right, before you move to the next slide, make sure you understand how I did this one before we get into harder ones. Here comes example 1 if you're ready. It says, write the statement symbolically and construct a truth table to determine if it is a self-contradiction, tautology, and/or an implication. The statement in English says, all Americans love baseball and Justin Bieber. Well, when I lived overseas in Africa, some people would always say, hey, you're an American, you must love baseball or Justin Bieber. So this made me write this example. So if you don't believe this is true, well, let's look at our truth table and find out. So take a look here. All Americans love baseball and Justin Bieber. So there is something we haven't really talked about a lot, and that is the word all. When we see the word all in a logical statement, that is the same thing as saying if then. So maybe make a note here. When someone says all Americans do blah, 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 they're really saying if you are an American, then you must do blah, blah, blah. So when I see the word all, I'm going to always make this an if then. Okay? So I'm going to rewrite it as an if then. I think that's a good practice for you to get in the habit of doing. You see an all, rewrite it as an if then. So if you're an American, then you love baseball and you love Justin Bieber. Okay. Okay, so how would I write this symbolically? Well, we could say loving baseball could be like letter P, okay? But is there something that becomes before loving baseball? Should I go back a little bit? Yeah, let's go back a bit. Isn't there something before loving baseball? If you look at my if-then statement, it might become more obvious to you. Yeah, if you're an American. So if you're an American could be statement P. Loving baseball could be statement Q. And loving Bieber could be statement R. Okay? So now could I rewrite this symbolically? Maybe you have already, or maybe you want to pause it and try it yourself. Well, if I know if it's an if-then statement, I'm going to have the conditional arrow to the right, okay? So if something, then something. If P, that says if I'm an American, if you're an American, then two things happen. Q happens and R happens, right? Q being you like baseball and R being you like Bieber. But notice we're not done yet, because if you're an American, you're supposed to like both of these things together. And how do we typically show togetherness, one idea, one thought, in logical symbols? That's right, parentheses. You must write the parentheses here. If you don't, you're saying something different. You'd be saying if you're an American, then you like baseball. Oh, and by the way, you like Justin Bieber, but not because you're an American, right? So being an American forces both of these two things to happen at the same time, according to this person's statement, their generalization. Okay. Now at this point, see if you can pause the video if you haven't already and build the table yourself. All right, so to begin with, for your entire truth table, how did you know you had 8 rows? That's right, there are 3 simple statements and 2 to the third is 8. Good job. How did you get your P column? Hopefully you did half true. I used a lighter blue, but that's okay. Half true and then half false, right? So let me grab my red for false. How did you get your Q column? Instead of 4 by 4, you went 2 by 2. So true, true, false, false. True, true, false, false. And how did you get your R column? That's right. Instead of 2 by 2, you went 1 by 1. So true, false, true, false, true, false. Get my other color here. They actually sell multicolored pens, or you can use different color pencils, whatever helps you to stay organized. If you don't like colors, then feel free not to use colors. Okay. Well, to continue now, what I'd want to do is ask myself, are there any things in parentheses that I need to look at? And yes, there is a big parentheses right here, Q and R. So I would make a Q and R column. Notice I don't need to go any smaller steps here because there are no negations inside, right? If there were, we do the negations first. All right, and then finally, I could put them all together, right? Because there's my P column at the beginning, my Q and R column here. Yeah, I can put them together now and write P arrow, so if P then, parentheses, Q and R. And there's my entire statement symbolically. Okay, if you haven't already done so, pause the video and try filling this in yourself. Okay, the first one would be like our last video when we had an and statement. So we're looking at the Q with the R situation. Let me grab a color to put them together here. Q and R. So that would be these two statements, the second and third column. Comparing them side by side, what has to be true for an and? Right? For an and to be true, they both have to be true. Does that ever happen? Well, yeah, in the first row, they're both true. Q and R are both true. So that is a true statement. Does that ever happen again? Well, I see it happening, yeah, in the fifth row. Both Q and R are true. But none of the other times does that happen, so the other ones would all be when it's false. That statement is false in those cases. So in two cases it's true, in two cases it's false. Now we're ready to build up the entire thing. Because it's an implication, let's look at our new notes if we have them in front of you. We're looking at if P, then, parentheses, Q and R. So I'm looking at the P column as my first. That's really important. Sometimes I even write down your first, okay? So that's my first column. And my second column is Q and R. So your second. I write that sometimes because it's important when you're dealing with the arrow, which one came first, right? So you're dealing with this direction. If P, then Q and R. Now for an if-then statement, feel free to look at your notes if you haven't memorized it yet. When is an if-then statement false? When the first is true and the second is false. So remember, in this case, if T, then F, then you're false. So that's the only time that happens. So do we see a T followed by an F when we compare those columns together? Well, let's see. I see a T first in the first four cases, right? So those are the only possibilities. And then I see an F for the Q and R column those three times, right? So in these cases, we have T and then F, right? The order matters here. So in those three cases, that's when that statement would be a falsehood. In all of the other cases, it would still be a true promise, or a true generalization in this case. Okay? So in some cases, this is a true statement. In some cases, it's not. So would this be a self-contradiction, a statement which is always false? No. Would this be a tautology, a statement which is always true? No. Could this have been an implication, and is it? Well, it was an if-then statement, so it could have been an implication, right? But is it an if-then statement which is always true? In other words, a tautology as well? No. Therefore, it's not an implication either, okay? Again, see if you can do this one on your own. Pause the video, try it again until you're really comfortable before you go to our next slide. Okay, in our next slide here, we're going to introduce one more piece of notation, and I promise this is the last new thing today. A biconditional statement, which was our double arrow, looked like this, P, if and only if Q, is true, so now we're worried about when it's true again, is true when both P and Q, so both of them, have the same or true? No, have the same, let me get another eraser here, started my S wrong, there we go, have the same values. Notice it doesn't say they both have to be true, okay? The same. That means even if they're both false, that's still a true statement. So as long as they both have the same value, they are what we call equivalent, or in this case, a biconditional statement. They're saying the same thing. So when this one's true, the other one's true. When this one's false, the other one's false. This is a biconditional, okay? So look, for example, at the truth table they built for you. They have a nice complicated one where they have, as their final statement here, parentheses, P if and only if Q implies P and R. So if and only if Q, then P and R must happen. Okay, take a look at the result here. We have some truths, we have some falsehoods, so it's not a self-contradiction and it's not a tautology. We can see that, okay? Therefore, it can't be an implication because it's not a tautology, right? So what did they do here? Well, they built out their three columns for P, Q, and R with 8 rows because there are 3 simple statements. 2 to the third power is 8. Then they got their biconditional. I want to take a look with you real quick at how they did that. How did they get this column here? P if and only if Q, okay? So they're comparing the P column with the Q column, these two, and the connective is if and only if, the double arrow. So we just learned, and you want to add this to your note cards, right? We just learned that an if and only if, or a biconditional, is true when they're the same value. So in the first case, are they the same value? Yeah, they're both trues, aren't they? That's why this is true. That happens again in the second row, doesn't it? They're both trues. That's why this is true. That doesn't happen again until the bottom here when they're both falsehoods in the last row and the row before it, the 7th and 8th rows. They're both true again, okay? So again, the biconditional will be true when they're both the same, even if they're both false. That's different than and. Remember, and had to be both true. But if and only if just has to be the same. So make sure that's in your notes. And then to do the next part, that's like we did in our previous video, where we were talking about the and conjunction, right? For an and, like P and R, we're looking at the P column, looking at the R column, right? And we're joining them with the connective and. So for an and statement, they had to both be true. Good. Let's take a look when that happens. In the first case, true and true, that's a truth. In the second case, doesn't happen. In the third case, it happens again. True and true, that's a truth. Doesn't happen again in the next case or the next cases, right? So it only happens in the first and the third case. And then finally, we put all this together with our if-then connective. Okay, for the if-then connective, this arrow here in the middle, remember that an if-then is only false when the first is true, but the second is false. That is when we get our falsehood, right? For an if-then. So let's take a look if that ever happens. Who are we comparing again? Let's take a look carefully. We're looking at the column with P if and only if Q, so we're looking at this column here. And we're looking at P and R, so this column, and we're doing the if-then, where this is the first and this is the second. Remember, the order matters for an if-then. So if the first is true and the second is false, then it's a falsehood. Does that ever happen? Well, we have T here and then truth, so that's not a lie. Oh, here it is, T and then false. That's our falsehood. Does it happen again? Not for a while, but at the bottom it happens in these two cases, doesn't it? T and then F, T and then F, so we got two more falsehoods at the bottom. So this is an example of putting together all the pieces we've learned so far. You have your biconditional, which is true when they're both the same. You have your and, which is true when they're both true. And you have your if-then, which is false when the first is true but the second is false. Now, is this final outcome indicating that this statement is a self-contradiction? No, because it's not always false. Is it indicating that it's a tautology? No, because it's not always true. And thus it can't be an implication, even though it was an if-then statement, because it's not always true. Let's see if you can put all this together in your next slide when you're ready. Example 2. Write the statement symbolically and construct a truth table to determine if it is a self-contradiction, tautology, and or an implication. So we have a nice simple statement. Let's take a look at it together. It says you will earn an A in this class. So that's like one simple statement. I'm going to call that P. Again, feel free to pause and try it yourself. If and only if, there's our connective, right? If and only if, you earn a 90% in this class. That's another one I'm going to call Q for that simple statement. So in symbols, this is a nice simple one. P and Q are being connected with which symbol? If and only if is our biconditional. Good job. The double arrow. Now this is a skinny double arrow. We're going to learn more about the fat double arrow in a future video. But this is just one line with two arrows at the end. Okay, so if and only if is the connective here. P happens if and only if Q happens. So if P happens, Q follows. If Q happens, P follows. Okay, so let's see if this statement is a self-contradiction, a tautology, or an implication, or none of them. So to start off with, I made my 4 rows for my 2 columns, P and Q. I made half of my P's true and half of my P's false, TTFF. And then I did one by one. Hopefully you did too. TF, TF for your Q column. And finally, there are no parentheses to worry about. This is lovely. We've done much harder. There are no negations to worry about, so we can just write our statement the way it is. Yay! The statement is P, biconditional or double arrow, Q. If and P, sorry, I keep saying it if first. P happens if and only if Q happens. Okay. In order for this biconditional, because we're only comparing these two, P and Q, in order for this biconditional to be true, what had to happen? Look at your notes if you need to. It's only true if they're both the same. So are they both the same? Yep, in the first case, they're both the same, both true. So that is a truth. And in the last case, they're also the same, aren't they? So that is a true. Now, it's not a false, right? We don't take the same letter we see. We say, is it true? Well, it's true that these are happening at the same time if they're both true or if they're both false. Okay, so that's what happened there. The other two cases where there's a mixture of some type would be falsehoods. So is this a self-contradiction statement? No, they're not always false. How about a tautology? No, it's not always true. And if it's not a tautology, we know it can't be an implication. But to begin with, because it wasn't the if-then, it still could never be an implication because it's not conditional. All right, I think we have another example. Let's head to our next slide when you're ready. Here we go. This is a harder one. Brace yourselves. You can do it. Take a deep breath. Go get some tea. Come back. All right. Example 3. Construct a truth table to determine if the compound statement below is a self-contradiction, tautology, and or an implication. So pause the video, see how you do. Come back, as usual. So let's see how you did. Okay, the first thing you did, hopefully, was create a truth table for 3 columns, P, Q, and R, since we see P, Q, and R, as well as 8 rows, because 2 to the 3rd power is 8. And hopefully you made them half true, so 4 truths for P, and half false, so T, 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 and F, 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 F. 4 truths, 4 falsehoods. And then hopefully you did your Q, 2 by 2, true, true, false, false, etc., etc. Let me grab my red here. Okay. And then for your R, did you go 1 by 1, I hope? True, false, true, false, true, false, true, false. Great if you did. Again, you can have templates pre-made for yourself so you don't do that every time. But I would encourage you to make yourself kind of suffer through it at the beginning until you get the idea. All right, so next up, to build out your truth table so you can determine how many more columns you need, you want to look inside parentheses. Now these are called brackets rather. These brackets here are basically just another way of saying parentheses, but a lot of people don't like to see parentheses nested inside parentheses, and that's why they start using things like brackets and braces after the parentheses. But feel free to just replace them with parentheses if you prefer. That's all they're saying. So inside your first big idea, the first bracket, you have a parenthesis, and then you have a lot of connectives, okay? But notice you don't have any negations here. So we could actually work our way from the inside out with our first inside parenthesis. So I'm going to start here with the parenthesis inside of those brackets, which is parenthesis P, then Q. So I'm going to make a column for P. Let me use black so you can read that better. P, then Q. Oops, I want an eraser, not more yellow. There we go. Let's find black here. There we go. So we'll do black here. So P, then Q in parentheses. Okay, I guess that looks a little more brown, but okay. P, then Q. So remember for an if-then, we're going to be looking at the P column, we're going to be looking at the Q column, and we're doing an if-then. The order matters, right? If P, then Q. So our first is P, our second is Q. When is an if-then statement false? Do you remember? Feel free to look at your notes. An if-then statement is false only if the first is true, but the second is false. That's the only time an if-then statement is false. Okay? So let's see if that happens. Do we ever have T followed by F? TT, TT, oh, here it is, TF. So that would be a falsehood. Happens again in the 4th row, TF, so that's a falsehood. Does it ever happen again? No. So the rest of them, it's true. If that's still confusing, think back to my example earlier. If you didn't even meet the condition, which is what's happening when the F comes first, how are you going to call someone a liar for not delivering the promise? Okay? You can only call them a liar if you met the condition, but they didn't deliver. Okay. Now that we have if P then Q, we're going to continue building out this first bracket by connecting it with the or R. So let's do that together. Look at my black color again. Maybe I'll do purple. Purple. Here we go. So or R. Okay. So we're going to do parenthesis, P, then Q, close parenthesis, or R. All right. So what we're doing is we're looking at the last column, the P, then if P, then Q, and we're comparing that with the R column, right? We're looking at those two together. And the connective there is or. Now you might need to look back at your notes from the last video. When was an or statement true? An or statement was true when at least one of them was true. So looking just at those two columns, the R column and the if P then Q column, again, the order doesn't matter for R, sorry, for an or statement. Do you ever have at least one truth? Well, yeah, you have both truths in the first case, so that's true. You have a truth in the second case. You have a truth in the third case, but not in the fourth case. Look, they're both falses here. But in the fifth case, they're both true. Now, is that okay? Yeah, at least one, so one or more is true. And it happens in all the remaining cases, doesn't it? At least one truth. So it's only actually false in the fourth case, where they were both false. Okay, so we basically built here our first bracketed statement, didn't we? That was in our original. Okay, so we're going to come back to that because we have to use that as our first statement for the biconditional that we're putting together. So we'll come back to that. But now let's build out our second bracketed statement here, this bracketed statement. And we'll begin again inside the parentheses, P and Q. So P and Q. Do we have that column already? I have if P then Q, but not P and Q. So let me build that. P and Q. I need to build that column. So let's look again at the P column and the Q column. We did the if then before, but now we're doing the conjunction, the and. So what had to be true for an and to be true? They both have to be true at the same time. They're both true in the first case and in the second case, but are they ever both true again at the same time? Nope, just those two cases. So first and second case, the other 6 remaining rows, that does not happen again, so they're false. All right, and now we want to combine that with the if then are. If then are. So the if then arrow and the are. So let's write that out here. Parenthesis, P and Q, arrow to the right, are. Okay, so let's take a look at which columns that implies. That's going to be this column we just did, the P and Q column, and this column way over here. Let me erase what I had before here so you can see it clearly. Okay, this column right here. So we're putting these two together with an if then. Now that's important because the order matters, right? Our first and then our second, okay? Our first is P and Q. Our second is R. I think I put it almost in the right place. I see now I didn't quite go far enough. So if you're panicking, Professor, don't do it. Thank you for seeing it. Okay, there it is, the R column. Okay, so first and then second. So make sure you have the right ones. This column and the second. Sometimes it helps just to kind of make it very obvious to yourself. All right, so when is an if-then statement false? We talked about that already on this slide. Can you see it? That's right, we did it over here. An if-then statement was false if the first is true but the second is false. So let's see if that ever happens. Order matters here. The first is true, that happens in the first case, but the second is true, so that's okay. First is true in the second row, but the second is false. So this would be one of those situations where it would be a falsehood. Does it ever happen again if all of the conditions aren't met? No, those are all true statements. The only time it can be false for an if-then statement is if the first is true but the second is false. So the other ones have to be all true here. Okay, so keep in mind how much the order mattered there. Had I accidentally done R then P and Q, this would have looked very different. Okay, so make sure you make a note to yourself. Order matters with the arrow to the right, the conditional. So now we've built out our column for the second bracketed statement here after the biconditional. And finally, if you want to be a little lazy, you could just say, I'm going to do a biconditional. Okay, but really what you're doing, you could call this like statement A, statement B. You're doing A if and only if B, okay, to make it a little easier to write. But really, in reality, you'd see this written out completely, the entire statement. Copy and paste, if you will. All right, so we're going to look at this column here. This is like my A column. And we're comparing that with my B column, my other bracketed column. So looking at these two in the red that I've just bracketed here for you, we have an if and only if comparison to make. So when is an if and only if statement or a biconditional true? When they have the same value. Good job. So in the first case, they're both true. So that would be a true condition, wouldn't it? That's a truth. Good job. They're both the same. Doesn't happen again in the second, but it does happen in the third. They're both true, so that's a true. Not in the fourth, but it does happen in the fifth, sixth, seventh, and eighth. And notice this would have also worked if they'd both been false, so as long as they're the same. So in one case, one lonely case right here, where we had a T and then an F, that's where we had our falsehood because they weren't the same. If they had both been falsehoods, though, it still would have been okay. It would have been true. Okay, so our final column should look like this, unless I made a mistake somewhere, in which case email me. TF, and then TTTT all the way down. 6 T's. Okay, so to answer their final question, was this statement a self-contradiction? No, it definitely was not always false. Was this statement a tautology? Almost, right? If this condition hadn't been here, if the second row hadn't been a falsehood, this would have been a tautology. So not quite. Could this have been an implication? Well, even if it was a tautology, it couldn't have been an implication because it's not an if-then statement. It was an if and only if biconditional. Okay? All right, so we've done quite a bit in this video. We've talked about truth tables for the biconditional. We've talked about truth tables for the conditional, and you had to remember all of the old information from your previous video. So if you feel overwhelmed and you need a break, that makes perfect sense, okay? So once you've taken that break, come back, look at your notes and practice, because remember, math is not a spectator sport. I'll see you next time.